Good morning, Mary Beth. Are you able to hear me? We all good?
I can hear you.
Wonderful. Thanks everybody for coming out and joining us this morning. We are going to be talking about designing cloud-first web applications in Azure. Appreciate everybody coming out. So let me introduce myself. My name is Shane Milton. I am a technical architect with Clean Slate. We are a Carmel-based consulting company. We have an emphasis in the cloud, and we do everything from assessments, integration, migrations, development, design. Pretty much anything cloud-centric is what we focus in. Myself, I have been working with Azure since October of 2008. The day Azure was publicly announced was the day I built and deployed my first Azure-based system. There weren't actually go live licenses for another year plus, but I've been in Azure for the better part of the past decade, and it's been my playground, and I've loved it there. As you can see here, I've got two wonderful motivators in my life, and these two ladies mean everything to me. So where I'm coming from, I've got a lot of cloud history, but first and foremost, I'm a dad and a husband, and those sorts of values are very important to me and what I bring both to my company, my colleagues, as well as my customers and clients. So real quick, I want to talk about what we're going to talk about today. I presume my audience is going to be a variety of technologists today, whether that means you're new to the cloud or you're new to Azure, or even you're familiar with Azure, but you want to learn a little bit more about Azure and what's offered there. I'm hoping my talk can bring value to all those people there. So we're first going to talk about a few things that are very specific to the cloud in general, regardless of what platform we're talking about. And then we're going to talk about some Azure specific things. Once we wrap those up, that will give us some context to then start digging into our conversations around designing cloud-first web applications. This first slide, it contains a whole lot of information that is going to be incredibly interesting to a lot of management people. But since my audience are more of the technologist type of person, I'm really going to focus on a few things that are really more important to us technologists. So businesses, both large and small, have been building cloud systems for a decade plus, and there are a lot of metrics on how these projects have gone. Whether that means they've gone great, they've gone poorly, but what all this data has, all this collected metrics, all this data has really emphasized is that building projects in the cloud is a more efficient way to do it than building it with on-prem systems. This means that just the general efficiency of the team goes up, the cost goes down. If that means being able to build the system and get it to production quicker, that means it saves you time as well. So not only is it about the cost, but it's also the time to market. There's much less time spent provisioning equipment. In fact, there's almost no time spent provisioning equipment. It's not a 2-week or 2-month thing. It's a 2-minute to 20-minute thing. Now, the next thing I want to talk about with cloud in general is that there are a few types of cloud projects. These types of cloud projects that we see tend to follow a bit of a spectrum here. On the far left side, you've got what's called a lift and shift. That's where you take your on-prem system pretty much as is, and you just ship it up to the cloud, put it on cloud infrastructure, do a lot of testing, and then you're good to go. Most of the efforts there are around testing the system. There are sometimes efforts around migrating data and moving technology assets, but your largest effort for these types of projects are really around testing. Next, there's what's called an opportunistic hybrid integration. This just basically means you're going to peel pieces of your system off and move it up to the cloud in a way that makes sense and is easy to do. So if you have a 3 a.m. process that generates nightly reports, even if you move that piece to the cloud and it's got a slower connection to the database, nobody's really going to care if those reports get generated at 3:30 instead of 3 o'clock in the morning. So that would be an example of an opportunistic hybrid integration. Next, you've got a partial design. This is kind of like a lift and shift, but where certain things have to be recoded, whether that means a specific feature or pulling out a specific library and replacing it with something else that's more cloud friendly. This partial redesign, it just means you've got some redevelopment effort, but it's not the whole application. It's just some components here and there. Now, the flip side, some applications really just aren't going to work well in the cloud, or you may choose to rewrite them for other reasons, whether that means to evolve the application or to make it fit cloud services in a better way. We've got to rebuild, rewrite there. And then lastly, you've got greenfield development, where it is just new development in the cloud and you start with a clean slate. For this presentation, we are going to be focusing on the two far ends of the spectrum, and we'll get into why we're focusing on those ends here in a little bit. Now, the second thing that I want to talk about that's kind of a cloud-specific topic is this term serverless. As you can tell from the title of the slide, serverless is used in different ways. There's little s serverless. That's where it's a general concept. There's big S serverless. That's where there is a strict definition for what serverless really means. And different people on this, in my audience right now, will have different definitions on what big S serverless means. So that's where we've got the serverless with all the crazy letters. Since you're watching my presentation, you're going to get my opinion. And my opinion is that I use the term serverless to mean a general thing that follows certain principles, and every one of those principles has nuances. The reason I have this opinion is because in reality, there are different definitions for serverless. And if you don't accept that, you're going to be in for a bad day. It's better to understand the general principles that they will all follow, and then to research and understand the nuances of every single one. So those general principles. The first one is that these services are generally built in a way that reflects how heavy you're using them. That means if you're not using the service for a week, you shouldn't really be billed a whole lot for that whole week. If you're pegging that serverless all the time, at least from an 8 to 5 period, then maybe you should be paying a lot for that 8 to 5 usage and then nothing else from 5 p.m. till 8 in the morning the next day. Secondly, the hosting of a serverless service, the emphasis there should be on your application and the value it provides the users. The emphasis should not be on the infrastructure. Most of the infrastructure should be abstracted away. There might be some hooks and triggers for you to manipulate it a little bit, but for the most part, your focus should be on your application and its features and functionality. And then third is scaling. All serverless services should have easy and automatic scaling. Now, some serverless services claim that they have infinite scaling, but that's not something that really is something you want, because with infinite scaling also comes infinite billing. And if you really want to dial this thing up to infinite, well, be ready to write that check for infinite as well. Now, those are all the principles that serverless follows. There is one other thing to talk about, though, and it's this thing called a cold start penalty. Most serverless services will have a penalty after they have been idle for a long enough period of time. So if you do have an 8 to 5 usage and nobody's used the application, that first person who logs in the morning and hits it will suffer this cold start penalty. And what that really means behind the scenes is there are servers. You have an application. That application is stored in disk and sometimes stored in memory and initialized. Well, if it's been idle for hours and hours and hours, it's probably no longer in memory, and it probably has to be loaded from disk and reinitialized. So that's the reason there are these cold start penalties. Next, let's talk about, and this is the final cloud generic thing that we're going to talk about. It's this thing called a services spectrum. And this is where we are talking about the range from an on-prem type of service to the various types of cloud services. IaaS, infrastructure as a service, it's a cloud offering where the cloud provider has taken the nuances of all the hardware out of your concerns. You don't have to be worried about hardware going down. There's a team of IT people managing that hardware and maintaining it, but you get to manage the operating system sitting on top of that and everything above that operating system. But that means you have access to anything the operating system can do. For example, you might even be able to rebuild and use custom kernels in Linux, for example. But that also means you need to maintain that operating system. You have to keep it patched. You have to secure it. You have to fix things that break. And all of that is on you. Now, the pass column here, the platform as a service, this is actually where I prefer to operate as much as possible. Personally, I don't like managing an operating system, keeping it secure, patching it. That's not what I want to do. I want to build a system. I want to build databases. I want to be able to bring features to my customers. And that's what I want to do. So I would rather pay for a pass offering and leverage in whether it's Azure with Microsoft or AWS with Amazon. I would rather leverage their IT specialists where they have teams of people working 40 hours a week whose sole purpose is to keep operating systems secure. I would like to leverage that so I don't have to do that. And then lastly, software as a service. This is really kind of a turnkey solution. I generally want to be building software as a service. I don't generally consume software as a service. I want to build software as a service. Now, how this applies to Azure. So software as a service is the first thing to talk about. It's easy. There's not a whole lot that we really want to consider consuming in Azure that is software as a service. As I said, that's what we want to be building. One notable exception might be Office 365. There are a few products that fall under the Office 365 umbrella, but what we're consuming as technologists generally tend to fall in these other two categories in Azure. That's PaaS, Platform as a Service, and IaaS, Infrastructure as a Service. Now, Azure's roots were really in the PaaS offering, and that's really what hooked me the day that it was announced and the day that I built my first application. Prior to that, I was managing VMware servers and Hyper-V servers in order to have a pseudo IaaS offering. So that way I didn't have to manage all the nuances of the hardware for the most part, even though I was managing those VMware and Hyper-V servers. But that gave me an IaaS setting to start building systems in. When I hopped into Azure that very first day, that was the first time I was ever introduced to a PaaS offering, and it was just eye-opening. And I realized that I could spend so much more time creating value for my customers and clients that without managing all these other things, even if I had to pay a few bucks here and there for somebody else to do it, it was totally worth it. So that's really what pulled me into the cloud and pulled me into Azure. Now with Azure, the rules of thumb for how things are built they are very well aligned with AWS for those of you who are familiar with AWS. There are certain services and bandwidths that they bill you for, and there are certain services and bandwidths that you kind of get for free. GCP, Google Cloud, it aligns pretty well to this. There are a couple nuances that are a little bit different, but it's still, this slide could be used almost universally for most cloud platforms. Now, the last thing that I want to talk about with Azure before you really start getting into cloud first web application design is just the sheer variety of services that are offered in Azure. These numbers would probably change if we pulled it up for AWS, but the point being with Azure, there are so many services in so many areas. If you're looking for a cloud service of some type, it's probably there, or something very similar is. I counted over 200 services available as of about a month ago. I'm not sure if that's changed, but there is a service for almost any need you have. Okay, so this is where we start getting into the good stuff. This list is not something I found on the internet anywhere. This is the list of things that I kind of provide to people I'm mentoring as they're getting started in Azure on how to focus and emphasize what they're trying to build and how and why they're trying to do it. So these rules of thumb for cloud first design, it starts with the very first one here, and that is to leverage SaaS and PaaS as much as possible. When you're asked to go build a system, your very first question should be, do I really need to build this, or can I go buy it for cheaper? That's where SaaS comes in. If somebody else has a SaaS offering that does exactly what you need, it is usually cheaper to go buy it than it is for you to build it internally. That may not be the right answer for everybody, but that is a question you should absolutely ask. Otherwise, you should try to build everything on top of PaaS as much as possible and as much as makes sense. There may be some times where you have to drop down to IaaS, but always try to build on PaaS. That will usually be your most stable, most efficient project. Next, it kind of goes hand in hand with what we just talked about, but it often saves you money by spending more money for a managed service rather than managing a service that you have to build and maintain. What that means, and this goes back to the use PaaS more than IaaS bullet point, it's that it's often cheaper to pay somebody else who has teams and teams of people dedicated to operating system security, to infrastructure stability, making sure that multiple parallel routes are going to multiple systems. It's better to be able to click those checkbox, pay an extra $10 a month for it, and leverage somebody else's expertise. So be willing to pay a little bit more for a managed service, and it may actually save you a lot of money in the long run. Next, let's talk about scaling. When you build a cloud system, you should plan for it to scale. And every project has different scaling needs, and there are also different scaling questions. when your system goes from 100 to 10,000 users, what does the price scale for that shift in volume? What kind of additional performance does your system need to provide to go from 100 to 10,000 users? And what kind of time to scale do you need when you provide that scaling? Is this a baseball card collection site where you're just sharing your database of baseball cards and you only have 100 users because it's a pretty personal site, and then all of a sudden CNN runs an article and goes viral and you have tens of thousands of users hitting it within an hour? That can have a very different answer for that time to scale question than what an internal business application has when it has a very cyclical cycle from 8 a.m. till 5 p.m. At that point, you just need to know you can scale up by 8 a.m. and you can scale down sometime after 5 p.m. And if it takes an hour to do so, that's no big deal. The fourth point, and we have a whole track in this conference on this, is automation or DevOps. When you build systems for the cloud, you tend to deploy them to the cloud much more frequently. There are a few reasons for that. One is, firstly, we are more prone to bugs and errors and problems in production today than we ever used to be. We are so interconnected with multiple systems, going over the internet to third-party systems, that sometimes you just have to be adaptable and identify and solve problems more frequently just because of these interconnected systems. Sometimes this just means that we have a faster development cycle because we have more efficient cloud-focused projects. And instead of it being a project that takes 2 months, we might be able to get the project done in 1 month, and we might just be developing and deploying more frequently than with on-prem projects. The fifth point I want to focus and emphasize here is security. One of my colleagues has really hit the nail on the head perfectly for this, and I love the way he states it. He's got two primary goals with his job. The first is to provide for his family. That's understandable. That's why most of us work. But secondly, his goal is to never have his name in the news. And that's really where security comes in. Building web systems, building cloud-hosted web systems, we are really prime candidates for any kind of attack. And you don't want to be responsible for having 100,000 passwords or 1 million health records being leaked online because you didn't consider security a first-class citizen. All cloud projects should consider security a first-class citizen, no exception. And then lastly, transparency. Transparency often means logging, but the thing I want to focus on more here is operational awareness. So what does this term operational awareness mean? This means understanding and knowing what's going on as it's going on. Does that mean all of a sudden my baseball card site jumped from 100 users to 10,000 users and there are errors being thrown all over the place? Does this mean that all of a sudden my system has started consuming a lot of bandwidth? These things that we're seeing and responding to may mean different things. It may simply mean, hey, we're having success with our system, but our monthly spend is going to go up a little bit because of the additional consumption. Or these things might emphasize that we have a problem, whether that problem is a potential security issue or just all of a sudden there are a bunch of errors being generated and thrown by the system. So how we perform this operational awareness is generally with alerts, with event-driven systems, with dashboards, but it's important to consider this at the beginning of your project, not at the end. With that, we're going to look at a couple examples. So I want to paint the picture of a pretty typical on-prem .NET application. That .NET application will be running on a server in some server room somewhere. That server will likely have IIS running on it. And IIS is just the platform for hosting .NET web applications that has been used for the past 20 years. That IIS application, that .NET application, will likely potentially have its data stored in SQL Server, and there is probably some disk storage used somewhere. That's a pretty typical .NET web application. Now, if we were to look at a lift and shift for that application, what we would move it to would be an architecture that would look kind of like this. And you'll notice this architecture looks very similar to what I just described. You've got users hitting this web application, presumably over the internet. That could be a LAN, whatever. And on-prem, we would have a server running the IIS server. In this case, in Azure, though, we've got this thing called an app service. And an app service is really just a different word for a cloud-based IIS application, at least in the context of .NET. So that gives you your hosting for your web application. It's an almost perfect one-to-one analog to IIS in a data center. And then there is this thing called Azure SQL Database. That is the Azure version of SQL Server. So it's something that you can generally very easily migrate a SQL Server-based database up into Azure and just have it hosting with very minimal changes, if any. And then there is also a thing called a storage account for storing blob storage, whether it means files on disk or what have you. That's where you store your files. And then lastly, there's a thing we're adding in here called Application Insights. That would be our logging system. And if you're familiar with tools such as Log4Net, for example, they have providers that you can drop in there to a point instead of it going to a local disk or a central store. Application Insights can be that central store for you. So this is what a lift and shift of a .NET application might look like. Now, this would be a pretty typical Windows example, but we don't have to stop there. We can take Clippy and we can replace Clippy with Tux, okay? That means we can really do the exact same architecture we just talked about. A couple details are different, but we can do the exact same architecture we just talked about for a Java app hitting Oracle, or for a Python app hitting MySQL. Whatever the technology is, the same architecture actually works very well with a different technology. It doesn't have to be .NET specific. It doesn't have to be window only. There is a whole lot of Linux operating up in Azure, and I want to make sure that that's something that is actually emphasized, because far too many people write it off, and it very much should not be. Next, we are going to talk about this hypothetical system that we're going to design. We're going to call this Smart Bugs. This is the revolutionary bug tracking system of the future. We're going to have billions of users of this system, so we want to make sure that this scales and is built cloud first. So the idea here is you're going to log in as a developer to this bug tracking system, and you're going to log a bug. You're going to save the data. Once that data is saved, well, the system is going to provide intelligence for you. It's going to go, as a developer, when I fix a bug, if I've got an error message, what's the very first thing I do if I don't recognize the error message? I go Google it. And what's the very first response on Google? It's always Stack Overflow. So we're just going to automate that process for us. So the moment I save a bug in the system itself is going to go ping Stack Overflow, hit the API there, get additional information from Stack Overflow, and pull it back into our bug tracking system. So that way, when a dev comes in to fix it later, they've got this relevant Stack Overflow information already tied to it. This is what an architecture for that might look like when done from a cloud-first perspective. This looks quite a bit different than what we looked at before. What we have here are a few specific PaaS services that we're utilizing here. Let's presume what we're building here is an Angular single-page app, and we're using Gmail to authenticate. Those details can really be anything, but let's just, for the sake of this conversation, let's say it's an Angular spa, and we're using Gmail for our social authentication. So let's talk about that security and that authentication first. In Azure, there's a thing called Azure Active Directory. It's often abbreviated by AAD, and it actually has a few different flavors. In this case, we're using the B2C flavor, that's business to consumer. All that really is a PaaS offering that abstracts all those social identity providers away from us. So that way we can just have a single interface to consume any of those that we want to. We would configure Azure Active Directory based on those different providers, but our application that we're building itself only has to have one link to this general identity provider abstraction. Next, we are going to store all of our static content in blob storage. This is the same thing as the storage account that we did discuss earlier for blob storage, but we're going to use it a little bit differently here. In this case, blob storage will, when storing this HTML, the JavaScript, images, and what have you, we can actually route endpoints to that blob storage directly. So I could have www.smartbugs.com go straight to this blob storage and host it straight out of the blob storage with no other changes. If I want to, I can put a CDN in front of that. That might be wise for scalability. But that's where all of our static assets would be. And we can also have that be whether it's public or private, that's available there. If you're familiar with AWS, this is just like S3. There are a few details that are a little bit different, but this is the S3 equivalent, this blob storage. So for our Angular site, we now have authentication. We now have our static resources, but we don't have anything dynamic. That's where Azure Functions come in. This is the serverless compute offering in Azure. And this is where we can build functions. Literally, I could go into the portal and just type in a function in one of 20 or so different languages and just get it running. I would probably do something a little more DevOps friendly than hand entering the code in a web portal. But I really get to manage my functionality at a function level. Each function by default, and I would use this feature, would have its own endpoint. So I don't have to put any kind of web end in front of these functions. These functions can operate as their own web ends. And as I build these functions, I'm really building the REST API that the Angular SPA is going to be referring to and utilizing. These functions will then store the data in this system called Cosmos. This is the serverless database platform in Azure. And once that data is stored, well, our REST endpoint would then come back and give the response to the user. And then from there, we have performed step one of how we describe this application. The dev or tester logs a bug in the system. Once that's done, well, Cosmos is going to fire an event to a background process that's also hosted in functions. Now, previously I said we're using functions for a REST API, which we are, but functions can perform other things as well. They are not just web endpoints. In this case, we are going to have a different type of trigger. For our REST API, we would be using what's called an HTTP trigger. That's how we say, hey, this thing should have a web endpoint, and here's some information about that endpoint. But in this case, for the backend process, we are going to have some sort of event trigger, and that would be a trigger based on new data being stored in Cosmos. And that's where we have our function go and call Stack Overflow's REST API, get additional data, and store it in our database. We could even do more intelligent backend things here, such as try to compare our current bug that was just logged to other bugs in the system, see if there are any other bugs that have the same error message, see if there are previous Stack Overflow questions that were flagged as being the correct solution to the bug, so we can pull that out front out of all of the Stack Overflow questions that we just now query. We can put the ones that were previously relevant at the top. There's a lot of backend functionality we could do here, but point being, your Cosmos DB database, being a serverless system, scales incredibly well, incredibly highly. The Azure Functions compute offering, it also scales incredibly well, incredibly highly, but both of those also scale down. When they're idle, you are not paying much, if anything, for them when they're idle. So, and then also the time to scale for both of these things can be very, very fast. When you build a system on these serverless offerings, your system is as slow as the slowest thing there. So it's important to consider that. If we were to put an on-prem database server that these have to go ping over the internet, you're going to be introducing a pretty major delay that's not going to necessarily scale well if you don't have a cluster of those database servers on-prem. This type of cloud-first design takes all those bottlenecks out of the system. So when your system goes from 100 to 10,000 users almost instantaneously, well, you actually have the platform that can handle that growth and scale, presuming you are willing to pay for that growth and scale. Now, one thing I want to say is that one of these things does not look like the other. On the lift and shift, what we have up in the cloud, it looked almost exactly like what we had in a data center. For the cloud first design, what we have up in the cloud is totally different. Some aspect of this is just because it's a Angular SPA, but the actual components we use on the back end, most of them are very different. We aren't using a traditional web hosting service. Instead, we are using a serverless service that has higher scalability, but it also often has faster time to get an MVP out there, so that way you can start adding initial value and iterating on that early version. The solution providers behind these things, on the left side, you would normally have an on-premise Active Directory, and If you ever wanted to switch from that to a social identity provider, well, you're probably looking at some pretty significant development effort. On the right side, if we decided we want to switch from this social identity provider to an Azure Active Directory, we would mostly just replace that left module with a different flavor of Azure Active Directory, and the connection between the application there would only require minimal changes. It would not be a major development effort. It would be more of a testing effort, but the development effort would be much lower than what it would be with the on-prem system. Now, something else I want to point out here, though, is even in the left side with the lift and shift, we actually are utilizing some cloud-first guidelines. For example, application insights. We haven't talked about that a whole lot. That is a system that where you can log to. It can provide metrics for it. It also has a whole bunch of dashboarding and events. You can even query the logs. It's a great place for log aggregation as well as operational awareness. In both cases, even with the lift and shift, you are starting to pull this serverless logging and operational awareness system into the architecture. Azure SQL Database, it is a one-for-one replacement with SQL Server, but it has a few different hosting models, and one of them even has a serverless hosting model if that's what's appropriate for you. It can scale up very, very high. It can scale down very, very low, all the way to free after a period of being idle. You still pay for the storage. You're going to pay for the storage no matter what cloud provider you're with. But the scalability there, it can scale from half a core all the way up to 40 cores or 400 cores, whatever you want the ceiling to be. And it would only scale up as high as it needs to based on the load. Point being, even in the lift and shift, it's still critical to consider these guidelines for cloud-first web design. Using these, you can build better systems, more stable systems, faster systems, more scalable systems, and you can do it more cheaply than what you can if you're not following these principles and guidelines. Okay, so that's the end of my talk. I really appreciate everybody coming out here. I've got a bunch of tools here and everything, but I'm going to skip over the slide and come right back because I've got a few more slides in the slide deck. I'll post a link to the slide deck in Slack. But these other slides are for people who are getting into Azure and want to learn more. This first slide here, if you were going to go spend 2 hours to go read about Azure, go read about these services. I showed you in the previous slide, there's 200 services in Azure. Start with these. If you're ready to go from there, well, have an idea of where you want to go. And here are some next services to kind of look at. These are compute services to start looking into. If you really want to jump in the Docker world, these are the services to look into. If you have questions around databases, data stores, data lakes, caching, start with these services. If you really want to start into application security, well, these are the services you want to look into. And here are a couple of the Azure Active Directory flavors. We use B2C, business to consumer. Well, there's also B2B, which means that's business to business. That's where you farm your authentication out to a partner's identity provider and let them manage their own users, whether that's a SAML endpoint or whatever that endpoint is. Next, if you're really into analytics and big data, these are some services to look into. There are some machine learning and AI services out there. And then lastly, that's not the end. There's just so much more out there. The one thing from this slide I want to point out are the penguins. There are so many Linux deployments and Linux services in Azure. Do not underestimate how friendly it is to Linux developers, Linux users. It's not the Windows world that a lot of people expect. And then lastly, this slide, when you're ready to go out and learn more in the space, here's kind of a step 1, 2, 3 of what I'd recommend. First of all, there are some tools called Visual Studio Dev Essentials. You get some free tooling there, free Visual Studio, and you also get a lot of free services in Azure. I want to say it's 6 months or a whole year of certain amount of free services in Azure. Definitely start there. And then once you get that set up, you're going to go to the Azure portal to start doing things. And if you have any questions around this or anything else, hit us up in Slack. If you're not already joined to our channel, there's a Slack channel called sponsor-clean slate. You can just search for clean and you'll find us. At the bottom of the slide, I've got a short code link that'll redirect you to GitHub where I've got these slides posted. And like I said, I'll post this in Slack momentarily. And feel free to reach out to me if you need anything at all. Happy to help in any way I can. And lastly, Clean Slate would like to thank you for joining us. We are offering for people who are interested a drawing for a couple services that we want to offer to you and your companies. One is an assessment with a tool called Cloud Checker. This is something that actually works in Azure, AWS, and some other areas, and we've actually had great success with this in the past. And second is just a planning workshop that we offer that's designed to help you build strategy, get most out of your cloud investment. Join us if you like, but thank you very much. Have a wonderful day.